Today I'm going to present a library which we are calling as quantumcat. So quantumcat is basically a cross-platform, open source, and to certain extent high-level quantum computing library. So what does this mean? So this means basically if I have to execute my circuit on multiple quantum platforms, I can do that using single syntax, right? So for example, I can create circuit using one single syntax, and I can execute on multiple quantum providers. So right now we are supporting Google Circ, IBM Qiskit, Amazon Bracket, IronQ, and Rigetti. It could be installed using pip install quantumcat. So just to show you the demo. So this is a Jupyter notebook. This library could be used just like any other library. So you can basically import a quantum circuit and give the number of qubits and put that circuit, let's say using Hgate in superposition. Now this is where the real magic is. So let's say if I want to draw a circuit, but I want to draw a circuit of Google Circ. So here inside that I can give the provider, and the provider could be Google provider, and I can execute it. So here you can see the circuit is similar to what Google Circ gives. If I want to execute it into into IBM simulator, I can change the provider to IBM, and similarly for Amazon. Um, and if I want to execute it, so similar to draw function, we also have execute function, using which with a single line of code, you can execute on any platform. So when I give a Google provider, here you can see the output from Google provider. The same circuit would be executed on IBM and Amazon as well. So based on the provider that you are giving. We also have created a function which is a compare result. So with a single line of code, I can compare the result on multiple simulators. So here the code would be executed on Google, IBM, and Amazon. So the same circuit would be executed on three different platforms with a single line of code. On top of that, you could also execute the code on the real device. So if I want to execute on IBM provider, I just have to provide the API from IBM dashboard, device on which I want to run, and the repetition. Similarly, if I want to run on IronQ via AWS, I can do it using execute function. And we also have created certain applications. So this is where we want to become a high level library. So you can see here, we have created random number application. Again, you can give the provider here, and it would be executed on Google provider or any provider of your choice. The best part is that a developer, for example, who is coming from Java background or any other platform, who generally is used to high level programming, don't have to worry about gates and circuit, right? So similarly, we have created application like password and OTP generator. So this library is open source. I would provide the link of this repo in the chat, right? And the link to the application that we have created. So we have also exposed this random number, password, and OTP generator as an API. So now it could be consumed in any application. So we have also created an Android game, which is Quantum Wheel. Basically where we are generating the slot randomly using our random number, which is exposed as an API. So this is about quantumcat. So if any questions, feel free to let me know.
Thank you so much for your talk. Any question for this amazing tool? Anyone?
I have a question. It's really difficult to integrate all these different platforms. What kind of suggestions or what approach do you use to integrate all these different platforms? At what level did you integrate them? By level, I mean, what is the input and output?
Yeah, so the best part is that most of them are written in Python and most of them are open source, right? So what we have done is basically we have created a wrapper around this library. So internally, we are converting the input, which are basically gates, which user gives, right? Like HGate, XGate, and so on. And then we are converting it into the equivalent gate in each of these platform. And if the gates are missing, for let's say if some gate is available in IBM but it is missing in Google, so we have created a custom gate so that the output is similar to any platform, so the user don't have to worry about it, right? And internally it would be converted as per the platform. So it's just like a Java compiler which converts into machine code, right? And basically user don't have to worry on which machine the Java is getting executed. Yeah, any more questions?
Hello. Can you send the circuits to real devices? For example, you have the function for random numbers.
Yeah.
You can send the circuits to, for example, the IBM quantum computer. Is that possible with this library?
Yeah, so are you asking if it is possible to execute on real device?
Yes. For example,
Yes.
that function, random number, that you're
Yes,
showing.
it is possible. And in fact, that is what we are doing in our Android application. So user has an option if he or she wants to run on a simulator or on the real device. So in the backend, we are calling random number, and here in execute, basically just like any execute function, you can give parameters such as API device. And if you give this API and device to this execute function, it is smart enough to understand that you want to execute on the real device, and it would execute on the real device. Of course, there would be some waiting time because it would be put in queue.
Wow. Oh, great. Thank you.
Yeah, thanks.